Hi, good morning to everyone. Thank you for being here and choosing my talk. Today I will give you an introduction to Bazel. First of all, a bit about me and that you know why I end up talking about Bazel. I work at BMW as a software engineer, and that is where I discovered Bazel. And during my free time, I just enjoy learning more about it. I did multiple contributions, and I decided that when I discovered Bazel, I missed some kind of a good introduction, and that's why I created this talk 5 years ago. And basically now I decided it was a good time to renew it and give an update to see what it changed, basically. First of all, let's then start. What is Bazel? Basically, Bazel is a build system. And we need to not confuse it with a build generator, like would be CMake. Bazel invokes directly the compiler. It has a full functionality for testing. It can generate test reports. It can generate. It handles flaky test. And the core of Bazel is written in Java. No judging there. But you can extend it. You have rules and macros and are written in Starlark. And Starlark is a language, you can see it as a subset of Python. That is one of the parts that make it nice, that usually it's quite user-friendly to read and to write. Let's start a bit on history. Basically, Bazel was not always called Bazel, was Blaze. Blaze is the build system at Google, at least it was back then. And the development of Blaze started around 2007 inside Google. But then part of Blaze was open source as Bazel on 2015 in a kind of a beta state, breaking changes every release. Quite unstable. Then in 2019, it went from beta to general availability in a much more stable way. And then a big change, in case that you knew already Bazel before, was on 2022. They introduced Bzlmod. One of the biggest issues that had Bazel was about dealing with external dependencies, and this was quite an improvement. And Bazel is a build system that is like multi-language. You can just use whatever language you want. We will see Python, C++, and Rust, but it supports Haskell, it supports JavaScript, whatever you name it, and it's extensible for your own language. It's just that at the beginning, several languages were embedded into Bazel from the start, like Java, C++, and Python mainly. And now there's quite a big effort on trying to remove these languages from the core of Bazel and just treat them like any other language. And this is helping to clean up a bit. Bazel was a bit messy in that regards due to that. And this is the main work going on right now. About the release process, that's always something good to know if you want to decide to use a build system or not. Since general availability uses semantic version, that's good. At least you know what kind of changes you might expect. There are rolling releases every 2 weeks if you like to live at risk or just use the latest and greatest. You can just every 2 weeks create a new release that comes from GitHub at head. But they also have the other extreme. They have long-term support releases. And usually every major release is released every around 12 months. And after a major long-term support release, the previous one goes into maintenance mode for around 2 years and then goes outdated. During the talk, you will see that at the bottom, I put some of the links. Later, for the different topics, if you want to go deeper, you can just go to the links. And the current version of Bazel is Bazel 8. Probably in the following months, Bazel 9 should be released, but we are still on Bazel 8 at the time of this talk. Let's take a look to the features. What makes Bazel attractive, at least to me? It's fast and correct. That's one of the features. It has incremental builds and test executions. The test executions are also incremental. It provides parallel execution by default. It has different levels of caching. Local cache has support for remote cache. And it has hermetic builds. It uses some file system sandboxing that provides some kind of hermeticity. It's multi-language and multi-platform. It supports Java, C, C++, Android, iOS, Go, Python. And yes, I put C/C++ here because even though they are two different languages, the Bazel handle it as one, unfortunately. And basically for the operating system, supports Linux, Windows, and macOS. I have to say that the support on Linux is the better one. Yeah, but nowadays the Windows support is quite good. macOS, I'm not using it so much, but I heard that it's also quite good. It's scalable. It can handle code bases of any size. That's one of the limitations that we had in my company, that at some point, like CMake was not scalable. And you can use Bazel on huge repositories, but also you can perfectly use it in a small repos. I use it for my private projects, small projects. I find it super handy. It's extensible. What does it mean? If a platform or a language is not supported, you can easily add that. It's not a big effort. I mean, of course, once you are a bit more expert, I would not recommend to a beginner to try to add a new language. And the extensions are written in Starlark. This is a language similar to Python. It looks like Python, it's just that it's a bit of a subset. They remove recursivity, they remove some other things, but in general, it's more like Python. We'll see a bit how it looks like. Now, let's see in a nutshell what is Bazel. You have different types of build systems, some that are more like task-based, some that are more artifact-based. And Bazel is an artifact-based build system. What does it mean? We have some inputs, and these inputs are provided to some action, and this action runs with these inputs and generates some outputs, and so on. And then how does it work is that these inputs are treated as artifacts. These are artifacts. Outputs are also artifacts. And the actions that you run are also treated as artifacts as well. Now, you have a bunch of artifacts. And for every artifact, you can compute the hash. But this hash, the nice part that you have is that you can compute the hash in advance before really generating the artifact. This allows you that you calculate the hash, and then basically this enables to have caching. And you can know, hey, do I have already that artifact there or not? And the calculating of the hash is extremely fast compared to generating the artifact. And maybe one last thing is like, okay, the outputs can be the inputs of, and you end up generating a full tree based on that. Each action runs on a sandbox. This is a file system sandbox. Of course, it still runs on the same operating system that you are running. It's not fully sandboxed, but it provides certain level of sandboxing. And this improves reproducibility. It has better detection of undeclared dependencies, because when you want to run this in a sandbox, what Bazel does is just copies more or less everything that you want. I mean, not really copying, but do some links into some folder, and then you run the things there. If you didn't declare some dependencies, the things are not copied and they will not be available. And this helps you to find undeclared dependencies. And a bit, what I said is composable. It means that like the outputs of an action can be the inputs of another action, and so on and so on. And then it's how you create the build graph. And an action can be also the output of another action. Like this means that this action that you run, that this could be the compiler, it could have been generated. Like the generation of the compiler could be part of the build tree. Okay, that's when it comes to the artifact part. Now let's see the design of Bazel, because that might a bit surprise you when you run it on some things that are going on. It uses a client-server architecture. But this doesn't mean that the server runs on some other machine and the client in your machine. What does it mean? Like when you run Bazel on command line or through the editor on your machine, the first time that you run a Bazel command, a Bazel server is started. And once the Bazel command finishes, the Bazel server will keep running. And basically now you might want to run a second command or the same command another time. And now what will happen is that it will reuse the running server. This allows that there's a lot of in-memory information going on that will stay in memory in the Bazel server, and this allows to have faster executions on every time that you run a command line. The only thing is that the Bazel clients cannot run in parallel. You cannot run two command lines in parallel. Only one can run. The other one will have to wait. You can always shut down the server if you want for some reason. If not, after some time, will also stop automatically. And this allows the server to cache information. And here you can already see the part of being fast. It's already built in the architecture. Now, basically, in Bazel, you have different modes. And this is something that if you would start nowadays with Bazel, or you already started a few months or even years ago, it might confuse you. Which modes we have? We have the workspace mode. This is a mode that was the only one, the one that has been historically there until Bazel 6. And the problem that had this mode is that it's hard to deal with external dependencies. It was very nice for a monorepo where you have all your dependencies in your repository, but in the moment that you want to import things from the outside world, that starts getting complicated. Because of that, what they introduce is this Bzlmod mode. And this is the one that it's available since some time in experimental. I would not recommend to use it on Bazel 6. Bazel 7, you might already start being able to use it, even though it had some bugs. Just use Bazel 8, I would say, if you want to go with Bzlmod. I think it's the safest. And this will be the only mode in the future. At least that's what is planned right now. And this allows some automatic resolution of dependencies when you have different parts of your tree trying to request different dependencies or maybe the same dependency. It will do some kind of automatic dependency resolution. If you are familiar with pip with Python, it's a little bit like similar style. And then you have a last mode that I would totally not recommend it. It's a hybrid mode. I think this more historically has been introduced for people to migrate. If you are in a workspace mode and you want to migrate to the Bzlmod without having to switch everything from one day to another one, it provides you this hybrid mode. But I would just recommend not to use it. And for now, let's just focus on the Bzlmod. This is the one that it's the new one. It's the one that we should focus. It's the one that you should be using, unless that you have a very good reason not to do that. And with Bzlmod, Bazel introduced the concept of a central registry. And you can have it available. And in this central registry, you have all the different third-party libraries that are available, ready to be used directly in Bazel. Like, okay, I'm in Bazel, I want to use Google Test, it's there. I want to use Upsile, it's there. Kite2, it's there. You might have a problem that maybe some of the third-party dependencies, they have not been done Bazel ready, I would say, and then you would not find them there. But the good part is that now with Bazel Central Registry and Bzlmod, you have a single place that you can see, is that available, yes or not? And this is also a way to if you are considering to use Bazel, maybe the first thing that you could do is check your dependencies are available here. If yes, that's maybe you can consider moving. If not, then maybe you need to consider what that means for you. Okay, let's start a bit on the Bazel files. Like any kind of build system, you have additional files that you need to add. And we have the first file that we have is the module.bazel. This is at the root of the source code. You have only one of them. It can be empty. You don't have to put anything. And this is the file where you will declare your external dependencies and also your toolchains. Then we have the build files. The build files are at the root of each package. In the moment that you put a build file, that defines that that is a package. And a package is defined by all files and folders that are on that folder where you have the build file located, except if you have another build file inside. And basically what we see here is that we have this package. And basically all of this is a package because it has this build file here. But now in the client, we have a build file. It means that this is then delimits another package. And then this is kind of a sub-package of this package. And then we have the Bazel files. These are the files that it's the files that allows you to use extensions. And this is something that you will have to use all the time. You will not have to write them all the time. You might have to write some, but use definitely, because as we said, Bazel is multi-language, and by default you have no language there. It means that you need to at least use some extensions for the language that you want to use. And this can be loaded in the build files with some load statements. Now inside the build file, we'll have what we call targets, and let's see how a target looks like. This is a target to define a C++ binary. And the first thing that we have is that for each target, we have the first thing that we do is we have this first line that we instantiate a rule. Like you have a rule. In this case, it's the CC binary that comes from rule CC, that is the rules for C++. And here you are instantiating a rule. In this case, we are instantiating a C++ binary. Then you have the name of the target, quite self-explanatory. We have the sources. Okay, this target needs to have these source files. That's the source files of our binary. Then you have some dependencies. Important here, it's only the direct dependencies. You don't want to declare transitive dependencies. And this would be like if your binary depends on some library, or like in this case, if this foo.cvp depends on some library, then you would declare the library in here in the dependencies. And then you have the visibility. This is a way to restrict which targets can depend on which targets. You are saying for who this is visible. And then last but not least, we have tags. And this is a way to basically annotate the targets, that if you want to put certain information, you can just do that. The different parameters that you have available, it will always depend on the rule that you want to instantiate. Some rules will provide you more parameters, some less. These are more or less the common ones that you will see in almost all rules. But then if you want to know specific information, you would have to do documentation of you go to the documentation of the CC binary, and then you can read all the different parameters that you have and what are available. And you see here the syntax that is like quite kind of Python-like a bit, like you have the list, this is a list, this is not a list. And this is the way to refer targets that we'll see now in a moment. Basically, we have targets, and now we want to refer to other targets. I mean, we saw that in the CC binary, we want to define dependencies. How do we mention other targets? Basically, these are the Bazel labels. And a label follows this form. you have the double @ then the repository name, and then / and the path until the package, and then your target. What you can do, you can decide to omit the first part of the label. And if you do that, it assumes that it's the current repository. It's not, you are not trying to refer to a separate or different repository. You can also decide to omit the part of the colon. If you do that, if you omit the last part of the colon, like we see here, then this is exactly equivalent. Basically what it does is like it assumes that when you are saying that, you are asking for the target called lib inside the lib package. And in case that you are in a build file and you want to refer just a local target that is defined in the same build file, you can just use the colon, omit everything in front, and that you are just saying, give me the target that is called like lib inside the same build file. Let's see an example. In this case, we have this repository. The repository is called example. And here what we are saying, okay, then this refers to the example, / which package, and here we go like the client. And then inside the client, we have the colon. It means that we'll go into this build file, and we're asking for this small client. And if we see here, this is where we have it basically defined. Here you have the same. In this case, you are referring the client. And if you wanted to refer to this client, then you could omit here the colon. Basically, these 4 forms are exactly the same as long as you are inside the example repository. We'll not go today into the topic, but you could be in some repository and refer to another repository. And that's why you might need sometimes to put the repository name in front. And in this case, if you are in this build file, then you could just, from client, you can refer to the small client just like that, or from a small client, you can refer to the client like that. Don't refer both. You cannot have cyclic dependencies on your build graph. It needs to be acyclic. Okay, target visibility. Now, we saw that there's a parameter that is the visibility, and this basically tells you who can depend on this target. You have different types of visibility. You can declare a target as private. It means that no one can mention to this target except the different targets in the same build file. This, when you have a target that is kind of like an implementation detail of this package and no one should depend on it, perfect, that's, you make it private, and that is the default. You don't have to spell it out. If you don't put anything in visibility, that means private visibility. You have the other extreme that you would say this target is public. Anyone in the whole code base can mention that target. You just do visibility public. And then you have the other option that you can say, okay, this target is visible from any sub-package inside the foo bar. You also have the option that you say it's only visible to all the foo bar package from that build file, the build file that it's immediately inside bar, not the recursively inside build files. In this case, you would have access to all the recursively inside build files. And visibility can be defined per target, like we see here, or you could define it per package in the build file, or both. And by default, the target visibility, if you don't put anything, it will be what you define per package. That would be the default. And if you didn't put anything, the default will be private. Exactly, that would be the last point. Okay, now one thing that is I would find useful to know when you work with Bazel is to know the different phases of a build. This is something that changed a bit with time, but let's just stay with the fundamentals. We have the first phase, that this would be the loading phase. In the moment that you, we'll see later how you run the command line, but in the moment that you do Bazel build, The first step is to load everything. It's the loading phase. You load extensions, you load the build files, transitive dependencies, you don't load dependencies. This usually it's relatively fast, takes several seconds. Of course, if you need to download some dependencies, it might take a little bit longer. But it's faster later thanks to caching. Then you have the second phase. That's also quite fast. It's the analysis phase. It makes a semantic analysis of the build tree. And it builds this dependency graph. It builds all the graph in memory. And it starts analyzing all the work that needs to be done. If you request for a target, then it starts computing, okay, what do I need to calculate? What are the targets needed? And this also, it's quite fast. Usually takes several seconds. And also it's cached. And then we have the last phase. This is the execution phase. And it's where the targets are built. This is where we spend most of the time. Like this would be invoking the compiler, invoking the linker, running the test. This is the main phase where most of the work will go. If your build takes 10 minutes, 95% of the time will stay in this phase. In latest, this was traditional like that in exactly this order. In latest Bazel versions, what they did is that they tried to melt these three phases, and they can a bit overlap in parallel. But it's not so much relevant. It's more like an internal, I would say, an implementation detail to speed up these phases. But what is important is that you keep in mind that you have these kind of three phases. And we'll see later, because you can do several things depending on the phase. Now let's go to the Bazel cache. Which type of cache do we have there? It provides different levels of cache. You have in-memory cache, the Bazel server, we already saw. It's lost or clean once the Bazel server is stopped. That's gone. Then you have an output directory that will be generated next to your code base. And it's local to your workspace. And you can remove it with Bazel clean, Bazel clean expunge. And then you have a disk cache that basically is a folder in your machine. And this can be shared between different workspaces. That's also pretty useful if you have to switch branches on your workspace. Then it's like you have that common disk cache. It can make quite a lot of usage of disk. You might have to clean it from time to time, because if not, we'll just keep growing. And then you have remote cache. And this is useful to share artifacts between, especially between your team members or the CI. If we are all here in the same team, most of the time we'll end up building the same things. And if you are building the head and I build head, I mean, probably that one builds it is enough. And then there is this remote cache that you can just grab individual artifacts. And when we are talking here about caching, we are not talking about caching the last final artifact that you want to build, the binary. We are talking about all these intermediate artifacts from the build tree. It could be that half of them, you take them from the cache, the other half you build them. Bazel cache is always valid and correct. That is something that if you need to take something from this talk, just take this. This is something that surprised me from the beginning. I was coming from CMake. I hope that this improved with time, but at least when I was using CMake a long time ago, I had to do at least a CMake clean, I don't know, every week or something like that. Now, the only reason why cache should be removed is to free space. As we said, if you have the disk cache or maybe a remote cache, at some point it will start growing. And you might want to do it to free space. If for whatever reason you solve a problem by doing a Bazel clean, that sometimes happens, well, what you need to keep in mind, that is a bug. That is not acceptable, like at any level. You have different options. It might be a Bazel core bug. By now, I would not expect to find any. I mean, if you find one, congratulations, you were the lucky one, but it's really stable in that sense. It might be in some Bazel rules, because when you implement rules for a language, it's especially when you implement extensions that you need to keep in mind these artifacts based system, you need to keep in mind the hashing, the caching, invalidating properly, and the sandboxing, the hermeticity. It could be that something was implemented wrong, and then it's a bug on the rules. It can also be that your toolchain configuration, you have some part that maybe it was not really sandbox. Maybe you are taking something from the system instead of from some artifact. Or it could be one of your Bazel extensions, that some of these macros that you can just create on your own and your project. But it's a bug. That's it. Like, do not accept it. Like, in the moment that you Bazel clean and you solve it, then create a bug ticket, please. Common setup. Basically, you would have in your machine, you have different workspaces, and here you could have the disk cache. When it comes to remote cache, this would be a recommended setup. I see that the lines, you don't see them. Okay, not so relevant. But basically, like, you have a remote cache on the cloud, and then basically, usually one thing that you might want to avoid is to prevent some, what it's called, cache poisoning. That for whatever reason, someone here, some developer playing around, messing around, it just accidentally generates an artifact that is just wrong, and it would upload the cache. And then one way to prevent that is you say, okay, the CI has read and write access to my remote cache, but the developers only read from the cache. But still, then you get a super good benefit. And if something poisons the cache, you know exactly who that is, because there's only one machine writing to it. That will not scale if you have a big company or a big team, because then the remote cache will end up being your bottleneck. But then you can consider some more distributed approach if you have multiple teams. Usually between the team, you are building more or less the same thing. And you could consider, okay, I set up a remote cache per team. That would be one approach that you could take. Depends on your organization, depends on your setup, you can just think about. And now let's see remote execution. Basically, Bazel compilation and execution, this can be in different machines. And here we have three scenarios. We have a scenario one, where you would say, I run Bazel on my machine. Then the application gets compiled also in my machine. And then I run the executable on my machine. This would be a classical, maybe desktop development that you do and you test on your machine and everything. You have the scenario two, also supported in Bazel, that you say, I run Bazel on my machine. This also compiles in my machine. But then the code that I'm generating, I'm maybe on a Windows, and what I'm generating is on Mac or an embedded device, and I execute it in a different machine. This is something that is also supported. But then you have the last option, that is where remote execution comes into place, that you would say, I run Bazel on my machine, but the compilation and the actions that we saw, when we saw these inputs, action, outputs, the actions that are running, they are running in a different machine. This is a way that you have then to parallelize the builds. And then you run Bazel on your machine, it compiles in other machines, and then you can execute it also in other machines. And this is quite embedded into Bazel. You have some commercial solutions for the Bazel remote execution that do some heavy lifting for you, but the whole protocols are built into Bazel. So far, this would be the fundamentals. I don't know if there's any questions. Yeah.
As a developer, any successful builds ends up in some cache?
Every
successful target build.
Every artifact that you build, it will end up in some cache, yes.
And a local or something like that. Is there any way to actually select between important ones and not important ones?
If there are ways to discard, I think yes. Like, basically, the question is more like about if every single artifact will end up in a cache. And basically, like, if you can say, okay, these ones I want to cache them, these ones I do not want to cache them. Yes, there are ways. And usually, sometimes you want to not cache for some other reasons, but also through tagging, you can do that. There are mechanisms to do that. But I would recommend you to think about why you don't want to do that, because I mean, like, if it's a space, it's usually cheap, but you can have still some reasons to do that. Yeah.
Maybe somebody has to change several modules actually to implement some functionality or something like that, and that is probably not interesting for others until it is done.
Yeah, I mean, but in that case, you might decide that you want to. I mean, on your local cache, it still might be useful, but yeah, you might find situations, and you can control that a bit. Okay, then basically, like, I will show you how you can do that with 3 different languages. We'll take C++, Python, and Rust. The beauty of that is that almost everything will look the same. And to me, that's the nice part. Like, you deal with all the languages in a more or less in a similar way. The first thing that you need to do when you want to use a specific language in Bazel is to load the specific rules. And you need to figure out where the rules are. And these are the pages for the different rules that I put here. But now that we have Bzlmod, it's just simple. You go to that simple Bazel registry, and you can search for Python, Java, Haskell, and you will see the convention usually is that they are called always rules underscore and the name of the language. And if you search for that, you should find it. In all of them, what you will do is you add a load statement in your build file, and you can just load the different rules that you want. For example, here we have some binaries or libraries, shared libraries, and test. With Python also we have binaries, libraries, and test. And for Rust, more or less the same. Now, once you have that and you have putting your targets, it's time to run your targets. And here it doesn't depend on the language. You just do Bazel run your target, and that runs. That's it. You don't care if it's Python, C++. For building, the same. Maybe in some languages, building doesn't make so much sense. And for test is exactly the same. And you can also use wildcards. If you do Bazel build ... you build everything. You build all the targets. This can and from all the languages. It's not about, oh, now I'm building only Python, now I'm building only C++. You are building all the languages. And the same for testing. You run all the tests. And that is where Bazel is especially good. If you have a repository with multiple languages, this is where it has the strength. And okay, it's like we have C++ and Rust that are compiled languages, but Python is interpreted. Why do you want to have a build system for Python? Well, usually it's more difficult to leak dependencies because you have sandboxing, and it allows you then to have a unified way to run your targets across the different languages. And basically, you have the benefit of all the test utilities that we'll later see. You still benefit from some parts of Bazel if you are using, if you use a build system for Python. Let's see an example. Okay, this is a C++ example with Bazel. We have some files, and basically what we do in the module.bazel file, we need to import the rules. We just do that. We declare a dependency, rules.cc, we want the version 0.2. And now inside our build file, we load these rules, and we say, okay, we want to have we want to have a CC binary and a CC library. And the CC binary, it will be called, the target, it's called hello world. And the sources will be a hello world.cpp. And then this depends on some library that we declare with dependencies. And this library is defined in the same Bazel file. This doesn't matter the order. It's a declarative language. And basically here in the CC library, you say, okay, your sources and your headers, basically. For all these examples, you can find here the link. Also on the second slide, I had a QR code, and basically like on my GitHub, you will find different Bazel examples. And you will find some additional ones that we will not have time to go through today. And when you want to run, Bazel run hello world, and you can build or build the library. For the test, we can just create a CC test target. We just declare here the test name, sources, and the dependencies to the library. That's it. And when you run the test, you just run Bazel test. You can put your target, and Bazel will just, in the end result, saying, OK, test passed, and how many seconds it took to pass. Example with Rust, similar approach. You go to the module.bazel, you declare your dependency, 0.63 version. On the build file, you load the Rust binary and Rust library. And then in the Rust binary, you put your sources, your dependency, and your library. Here you have the Rust library with your sources and your name. As you see, very similar. Same approach for running, nothing changes. It's the same command line, even though it's a different language. For the test, basically in Rust, usually you put the test inside the same library. There's no additional source file, and then you have this Rust test, and here you just, the way that they have to depend, it's with this crate. And that's a bit what I said. It will depend a bit which parameters you have available, depends on the language, but then always the recommendation is just go to the specific rule, check the documentation, and read which parameters they have available and what they mean. You run the test the same way. Python. Well, you can start seeing the pattern, I guess. You declare the dependency in the module.bazel, you load the file, you declare a PyBinary. The PyBinary depends on a Py library. And then basically, if you run it, perfect. If you build it, the command line is still there. It will just tell you there's nothing to build. I mean, what do you build in Python? Still, it will do some analysis. And if you run it, if you try to run a library, this is the same for all the languages. It will tell you, I cannot run it. It's a library. This is not specific to Python in this part. It's like for everything. And if we want to do a test, same process, exactly the same. And you start seeing the pattern. With most of the languages, unless that they are super different, usually it's like name of the language underscore library, name of the language underscore test. Probably there's a Haskell underscore test, Haskell underscore library, and so on. And the test. OK, but now it's we said that it's a multi-language build system, and we also saw that we can extend Bazel with macros and rules. Let's try to play around a bit on what we can achieve. Now we'll have an example. And in the example, what we want to achieve is that we have an input file, a text file. We'll pass it to a Python program. This Python program, what it will do is to generate a C++ file that later we will compile with our C++ toolchain and generate an executable. And what we want to do is that we provide as an input a text, TechTown 2025. And basically, when we run the Bazel run, it will just tell us, hey, hello world, TechTown 2025. And if we say everyone, then Bazel run, and it will just, hey, hello everyone. It's kind of a generator of hello worlds. How does it look like? OK, I mean, I could have done everything in one language, but the nice part here is to combine multiple, right? What we have here is that we have a small Python program that basically takes as an input.txt. And basically, what we are doing here in this part is that we write to the output file, we are writing hello world. Basically, we have the include iostream, int main, std_cout. And here we are just putting the content of this input file. OK, now we have our C++ code generator. You can solve everything with a generator. And basically, like, OK, this is a binary. We need to just declare it. We need to put it as a target. Even though this is an action, as we said, actions are nothing else than artifacts and targets. We declare our PyBinary. This is a generator. OK, we have now our generator defined. Now what we want to do is we want to have some rule. We want to have an extension that it calls this program with certain inputs. And we cannot go too much into details onto that. We don't have enough time. But let's take a look how it looks like, and that you have an introduction. Later, you can just go to the example and some of the links of the macros. Basically, this is nothing else than a macro. The first thing that we do here at the bottom is to declare a macro. This macro is called hello world. And each macro has an implementation. And now, basically, we need to implement this macro. And the macro, like in a lot of languages, is nothing else than expanding. It means that for Bazel, this is nothing else than whatever code is here. It's put directly in the build file. Approx, that's the approach. And now what we are doing inside the macro implementation, in Bazel you can have rules. Rules is what it's the way to really have full functionality. Like macro, the first level of extension is macro, but with macros you are relatively limited. And then you can create rules that it give you the full power. Now for relatively simple rules, Bazel provides you this functionality that's called gen rule, that it kind of automatically generates a rule. This is great for small dummy situations, but in general, you should not use it. For big things, you should just use a full macro, full rule. But here we'll not have time to see how a rule looks like and how to do that. But just you to know, if you want to extend more, then you need to look at rules. And here in the gen rule, what we'd say is like, okay, we'll have this target with the same name. And now basically, this rule, it has some inputs, some sources, and some outputs. And then basically these inputs, what it will do, if we see here from the notation that I'm using here, it will try to find a target that it's called the same name that we provide. Basically this macro, when you instantiate it, you can provide the name. It will try to find the target that it's name.txt. And that here we declare an output. This means that this rule will generate an output that it's with the .cpp file. And now here we have two parts. One is like, okay, what Bazel have to do to run that? And here you have like the command line. And here starts coming the interesting part. You do not know this target, where it will be located, where Bazel will put it. We said that everything is sandbox. It means that you cannot assume, you cannot put absolute path. You should not do that. That's usually a typical mistake that then people start saying, oh, this is not sandbox, this is not hermetic. What you have to do is you have this mechanism here to say location, that what you are saying to Bazel is like, wherever you decided to put that, give me the location, and that's how you then invoke it. And this is the way to say the input and output redirection. And apart from the command line, you need to be able to say to Bazel, which tools do you need to have available? In the moment that you want to run something, what needs to be available? And we say, okay, the generator needs to be available. And then this will be considered for the graph to say, okay, I need to build a generator, and then I can run that. And when you have this macro, now you want to instantiate it. And here, the way that you have to instantiate it is like you have this hello world, you give a name. And what will happen, for example, with this one is that this will try to search for something called NDC TechTown.txt that it's declared here. And then it will generate a name.cpp file. But that target generated is reflected by this name. And it will run the generator that we have created here. It means that this represents the NDC TechTown.cpp that contains that string. And now in the CC binary, instead of explicitly saying here a CPP file that you have hardcode, you are just mentioning this target above. It represents basically the generated .cpp file. And you could just then spawn this binary with a Python test to check if the binary do whatever you wanted, or with a Rust test. Like you can just concatenate and combine different languages. And this is something that I do all the time. Maybe you want to do tests with Python because system test is easier, and then you do the implementation in C++ and so on. But wait, if it is so hermetic, why did we not have to specify our compiler? In any of these examples, I said like, hey, use GCC, use Clang. Well, here there was some debate, I guess, and the thing is that if you would have to specify a compiler for every single dummy use case, the entry level would be quite hard. Basically, for practical reasons, Bazel, what it does is that it provides some predefined toolchains that can be used. Basically, what it does when you run Bazel build for C++, for example, it will try to find, hey, do you have GCC installed or do you have Clang installed? And then based on that, we'll try to just generate a toolchain definition based on what you have in your machine, and then we'll use that. This is great for starting, for playing. If you really want to have the hermeticity and reproducibility that Bazel promises, the toolchain needs to be defined manually on your own. And not only the toolchain definition, but also the compiler needs to be provided. It cannot be that that you define all the compiler warnings and everything, but you don't define which exact binary of the compiler, because maybe you have one version installed, I have another version installed. The best thing is that we get it from some common place. You have this option, toolchain resolution debug, that basically helps you to figure out which toolchain was selected. And as I said, for any production project, you should just define the toolchain. You also have toolchains available on the internet. There's the mechanism that you don't have to define your own. For the LLVM, is there. Rust also, Python also. It's something that you need to consider. And there's a lot of documentation about that. You can take a look. Also, I have an example on how to generate a C++ toolchain based on the automatically generated from Bazel in the Bazel examples links that I share. Let's see the test runner. What I said is that Bazel has some functionalities for running tests. This I find it pretty handy. When you run Bazel test, it runs a test. And all this infrastructure is language agnostic. You don't care which language that is. When you use wildcards, it runs all the rules that have this underscore test. And basically, you do Bazel test, --, and basically this means like the wildcards means everything. Just, okay, run all the tests. Except you can always mark test with a manual tag, and this means that it should be kind of deactivated or skip when you run it with the wildcards. You might have different reasons to do that. There's also the option to mark test with flaky. Flaky means, okay, this test sometimes passes, sometimes fails. We all know that it's bad to have flaky tests and you should fix them. But between the option between having them or not having them, you have the option in Bazel to mark them as flaky. And if you do that, in case that they fail, Bazel will rerun them up to 3 times by default. And if at least one of the times passes, then it's okay, it passed. But at least then you make sure that someone did not really break it for good. There's also, you can specify the timeout, and then basically like, if the test needs more than certain timeout time to execute, then it will fail the execution. Tests run always in parallel, unless that you put the exclusive tag, because we said that there's parallelism. It means that when you run tests, when you compile, everything runs in parallel. But if when you run tests, you specify exclusive, it means this test cannot have any other test running in parallel. This is something that you should avoid. If you have to do that, you should have very, very good reasons. If not, you are just defeating the part of the speed. And usually if you need to do that, it's because you need some global resource that you cannot really sandbox, but you have the option to do that. And the output of the test is stored in a file and displayed on the console in case that it fails. And you can also just stream it. When you run the test, you can just live see the log of the test. But this makes the consequence of that is that then the tests are not running in parallel if you are streaming the output. But for debugging, this might be quite useful, especially if a test hangs or stuff like that. On a library, you can set the test-only parameter. And if you do that, basically what it means is that only a test or a library that is marked as test-only can depend on this target. This is a way to kind of limit, like, hey, I created this dummy library that it's only for testing, but I would like to kind of make sure that we'll never end up in some production binary. I mark it as test-only, and this is a way to protect against that. And we said that has caching, but it's also for the test. If you run a test and the test, nothing depending on this test change, Bazel will not run it. It will just tell you it passed, and by the way, it's cached, that you know. And you have ways if you want to force the re-execution, but why to run it again if it did not change? And the report looked like that. These are the different types of the different outputs that you can get. A test that passed, but because it was already cached. A test that executed. A test that was flaky. Here it failed 2 times out of 3. And for this, it's kind of still answering like good. It's fine. It passed. But here you have the logs of the 2 failed attempts that you can take a look if you want, and you know that it's flaky. Here you have a test that it fails, and when it fails, it also shows you the log. It could be that the test directly fails to build, then it will also tell you failed to build, or it could be that the test just hits some timeout, and then it will just abort it. Bazel also have coverage. We don't have much time to go on to that. Just for you to know, there's a command line, Bazel coverage, but it's quite broken. It's improving. It's just a nightmare. Yeah, that's what you need to know. If you are familiar with baseline coverage, that's also not supported. You have it here. The good note on that is like, but people need it. And as we said, it's extensible. We did it. Like, you can do that. It's just that will be painful. That you know that there's an option, but it's not fully supported. But don't get overexcited when in Bazel you see Bazel coverage command line. It's not just magic. And for some languages, it's better than others. And I can promise, over the years, has been better and better and better. Then, it would be a pity. We saw that it's a artifact-based system. We built a build graph. And this build graph, it would be a pity not to use it. And basically, we have Bazel query. And Bazel query, it comes in 3 different forms. And it allows you to ask questions to this graph and to get information. For example, you have you run Bazel query, and you say, OK, I have this target here. And basically, now I want to know what are the dependencies of this target. And basically, Bazel will say, by the way, OK, yeah, this target depends also on these 2. This is the representation that I gave to you for the graph. And basically, like, this depends on the catch, depends on the foo, and you can see that there's no artifact here. And this is very good to see what are my dependencies on this target. I'm depending on gtest. Do I depend on that library that someone is planning to modify? Will this library end up in release? And you can also figure out path. Like, OK, tell me what is the chain of dependencies that goes from this artifact to this other artifact. And this is, it would just tell you the full chain, how you end up with depending on that artifact. In case that 2 targets, they do not depend on each other, it would tell you, I could not find any path, empty results. If you want to use Bazel, don't use Bazel, just use Basilisk. Basically, Basilisk is nothing else than a wrapper around Bazel. It's a launcher for Bazel. It's provided by the same Bazel team. And what it does is that it allows multiple versions of Bazel. You don't have to care. In a small file next to your repository, you say, I want to use Bazel version 7.3. And Basilisk, the only thing that it does is to read the information of that file. And I know that you want to use Bazel 7.3. I download Bazel 7.3 in case that you didn't have it, and I run it. And you can just, then you don't have to care about if in your organization someone updated Bazel or not. And you can put it in your path with an alias as Bazel. And if you want, you run it like that, or if not, you just rename it as Bazel. That's what I have. And just for you to know, there's an additional topic called aspects. We'll not talk about that, but that's just you to know. It's a way to generate a kind of a parallel build tree with additional information. And this can be used for static analysis, compiler warnings, code coverage, ID integration. These are more like advanced topics, but that just you know that exists. And here I put you the different command lines. We'll not go over them. We saw almost all of them. And yeah, that would be it. I think we are just in time. There's not much time for questions, but you can just approach me here now or then outside later, as you prefer. Thank you.